Between the rocky worlds of the inner solar system and the gas giants beyond lies a vast, dusty ring of leftover material, the asteroid belt. Stretching from roughly 2 to 3.5 times Earth's distance from the Sun, it contains millions of rocky and metallic bodies, from tiny pebbles to dwarf planet Ceres. Yet, if you gathered every asteroid together, their combined mass would still be less than 5% of our moon. So, why is this region filled with debris instead of a planet? And what does it reveal about the birth of our solar system? 4.5 billion years ago, the young sun was surrounded by a swirling disk of gas and dust. Inside this disk, particles stuck together, growing into planetesimals, the building blocks of planets. Closer to the sun, heat kept water as vapor, so the material that formed was mostly rock and metal. Farther out, ices could freeze, feeding the growth of the giant planets. Between Mars and Jupiter, conditions were just right for rocky bodies to form, but something prevented them from finishing the job. That something was Jupiter. As the largest planet rapidly grew, its immense gravity stirred the region violently. Planetesimals that might have coalesced into a fifth rocky planet were instead flung onto chaotic orbits. Many collided at high speeds and shattered. Others were ejected from the solar system entirely, or sent crashing into the sun or other planets. The survivors were left scattered across a wide zone, never able to gather into a single world. In effect, Jupiter starved the asteroid belt of the material and calm conditions needed for planet formation. The asteroids that remain are time capsules. Their compositions record the chemical gradients of the early disk, some rich in metals from the hotter inner regions, others laced with water and organic compounds from farther out. Many are fragments of larger parent bodies that were heated, melted, and differentiated, revealing that even small worlds once had molten cores. Impact scars and families of related asteroids show a history of violent collisions that continues today. The belt also preserves dynamical clues. Gaps known as Kirkwood gaps mark orbital resonances with Jupiter, where asteroids are repeatedly nudged until they leave. The presence of both primitive, unaltered asteroids and highly processed ones tells us the early solar system was a chaotic mixing zone. Some material from the outer disk was scattered inward, some inner material was flung outward. Planetary migration models even suggest Jupiter itself may have moved, further sculpting the belt we see. Today, spacecraft like Dawn have visited Ceres and Vesta, while missions such as OSIRIS-REx and Hayabusa 2 have returned samples. Each piece of rock and dust brings us closer to understanding the conditions that allowed Earth and life to emerge. The asteroid belt is not a failed planet. It is a surviving archive of the solar system's violent, creative youth, an unfinished chapter written in stone between Mars and Jupiter. Like and follow for more daily space facts.